We all watched the past Summer Olympics, watching those little girls sprint towards this so-called vault table, only to fly twice their height. How do they do it? How athletic do they have to be to run fast enough to fly that high? So our question is, what is the minimum velocity required for a gymnast to continue with their vault? Alright, let's get to it. So let's define some terms here. Velocity equals speed with direction. And acceleration equals change in velocity over change in time. So with dealing with objects in motion, we have Newton's 3 laws of motion. So with Newton's first law of motion, an object in motion will stay in motion until an outside force acts upon it. So this means if a gymnast runs with a certain velocity for a preparation of a vault, they will eventually change their velocity once hitting the springboard. Why is this? All the outside forces acting on the gymnast will help change their velocity so they can do the vault. These outside forces are friction, force due to gravity, force applied from the gymnast, and then normal force. Force due to gravity is basically gravity onto any object on the earth. Force P, that means the applied force of the gymnast to the springboard. The normal force, Fn, that means the force onto the gymnast, which we'll cover later into another law. And then force of F, that's force friction, which applies to any object coming into contact with another. Newton's second law of motion means the force vector and acceleration vector on an object point the same way, thus force equals mass times acceleration. So dealing with this equation, all of these terms relate to each other. If mass would increase, so would the acceleration, and vice versa with the force. Newton's third law of motion means every force has an action and an equal but opposite reaction. This means if a gymnast jumps on the springboard, they apply a force P, to the board, while another force from the board, Fn, is acting the same force on the gymnast. Normal force, applied force. So gymnast puts force on springboard puts the same amount of force on the gymnast. Now, how do we calculate the minimum velocity? Well, we do this by calculating the kinetic energy. Kinetic energy is basically the energy of motion, and energy means the ability to do work. So, let's look at this equation. This is kinetic energy is equal to 1/2 mass times velocity squared. We can find velocity by doing simple algebra here. What we do is we divide each side by KE, or kinetic energy, by 1/2 m equals to v squared. Then, to solve it further, we would square root the whole problem. So velocity equals the square root of kinetic energy over 1/2 mass. And that is how you would solve for velocity. Here is an example of a faulty vault. Because she runs so slow, she will not be able to vault.
I came to dance, 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 dance. I hit the floor cause that's my plans. I'm wearing all my favorite brands. Give me some space for both my